Hello and welcome to our talk. My name is Quinn, and this is Alan Bateman from Sun.
Hi.
We are talking today about new IO, or I mean,
more
just
new
two
IO.
news. More new IO.
More
okay,
new
that's
IO.
the official name. This is the same talk that will be given next week at Java 1 on Thursday. So if anybody's going, they could go to that and see it twice. We might be a little better next time. So we're just practicing on you guys. You're the guinea pigs. We'll get our timing right, and we'll hold off questions till the end so that we can go through it as if we were giving a Java 1 talk. Okay?
Yeah, I hope that's all right. It's just we wanted to get a dry run in here. It kind of worked out well for fit it in this week. Okay.
So, go ahead.
Start? You start?
Yeah, you start.
Okay. All right. So where are we here? Okay. Sorry, mandatory slide here just to introduce what we're going to talk about. So Carl and I are both working on something called JSR-203 that's actually defining a new set of IO APIs for the next version of the Java platform. So we have three objectives that we want to get through today, and they fit really the goals of what this JSR is about. So we want to teach you a little bit about just what we're doing around defining a new file system API. We'll talk about some of the work that we're actually trying to do to complete the socket channel API that was put into Java back in 1.4. So there was a lot of things that carried over from that needed to get finished off. And the third thing that we're going to just talk briefly about is a new asynchronous IO API that we have for sockets and files that we've been working on as well. So the agenda basically reflects the goals that we have here. We're just going to go through them in this order. I think, Carl, you want to talk about this. So the first thing we're going to just talk about is the file system API. So the Java platform today has got something called Java IO file that has been there since JDK 1.1. It provides very primitive access to the file system. So there's been a lot of problems with that and a lot of issues that we haven't actually addressed. There's a lot of features that it doesn't have. So we want to deal with those. So I was just wanted to quickly check whether I have no idea where people are coming from here. Do people actually use Java IO file? Are people happy with it? Okay. So, well, hopefully some of the work that we'll actually do in JDK 7 with this JSR will actually address a lot of the things that people have. So on the next slide, we have a list of generally the type of problems that we have with it today. And do you want to start on that?
Okay, sure. We've identified just sort of a high-level summary of some of the things that we thought of as goals. These are the issues that we want to solve with the new file system APIs. So definitely one thing is it doesn't work consistently across platforms. You're always having to fiddle around understanding what platform you're on when you're working with file. Many of the methods return a Boolean to indicate success or failure. So if something goes wrong, you get back a false. You don't know why. There is no more information about what went wrong. You don't really know how to handle the problem. So something richer, return type or exceptions were in order there. And the current files API lacks many of the basic features, such as copy and move and just accessing a lot of the information that you would need for a minimal application. Symbolic links, file change notification, none of that exists in the current old file API, and permissions and things. So, and it's definitely not extensible. You had one class, had a few methods on it, and that's basically all you had access to. So the new file system API, so this is part of the NIO package. So everything in the new file system API is under Java NIO file, pretty much. There are some methods retrofitted in existing classes to make things work nicely and fit together, but this is where they all pretty much live. So file contains most of the classes, interfaces, exceptions that you'll be using. And then file attribute, a subpackage, contains everything to do with attributes, accessing attributes on files. There's also a service provider API, which we'll talk about a little bit at the end, or you can talk to us later. But so that's mostly for people that want to write a file system. So the main four classes that you would deal with when you're using the new file system API is the file system class itself. So this is the interface to a particular file system. And a file system is an abstraction of a file system. It's not a particular volume or store. It's just sort of the abstraction onto a system of files. Like in Unix, all of the files in the file system would go through one. And there is a default file system that's created and available to every application, every Java application, that they can retrieve that default file system and work with that directly. Every file you can access has a file reference type, which provides the basic interface and methods that you can access to manipulate or access information about a particular file, but not necessarily know about its name. So that's where the path type comes in, and that's a file ref that also knows about its name. So probably when you're creating paths, like if you're replacing your old code that worked with file, you'll probably be using path a lot. So that's kind of the replacement for file. You can use a factory to retrieve one of those. You work with a file. You can. We'll go into more details about how path works. I got a lot of slides on path. And then a file store is sort of the representation of a logical volume or some kind of mount point within a file system. So oftentimes you won't need to use that, but if you do need to poke around and find out a little more details about a particular part of the file system, like how much storage space is left or what's consumed or any particular constraints about attributes that are supported on a particular volume, the file store takes care of that for you. So here's a quick example of some code using the new APIs. So you can see path being used at the top. We use factory method on path, the path class, to retrieve a path. And this one uses the default file system just for convenience. If you wanted to get a path from a specific file system, you go retrieve that file system and do the same kind of thing. But this is just a quick way to do solve very common problems. So we get a path using a string. Then we resolve a file below that path with the resolve method. So you can say home.resolve is resolving this particular file. You get back another path that represents that file. And then we're executing the copy-to method. In this case, we resolve another path to, as a backup name for the file, and then we're going to do a copy-to. So we're copying from the profile to the backup name. And so the copy-to method will actually perform, sorry about that. Go away, Google Notify. The copy-to will take care of copying everything, all the bits of the file, take care of any of the attribute copying. There's some options that you have there. You can play around with it, but it does all of the work. It's completely self-contained for you. And another example of using path and how it interacts with the other parts of NIO. Here we're creating a seekable byte channel on top of, or given a file name, and then we have a channel that we can work with. And so in this case, this example, we're writing things to the file, and then when we're done, we close it. So using path, we can get to other parts of NIO and other parts of the older IO system. Okay. So there are methods on path to access the components of the path. So path generally represents a name in a hierarchical file system. So there are methods that you can go through and find little segments of the path and walk through there and test and compare paths with each other to find out if one path is a prefix of another or if they're equal. And you can sort them lexicographically. There are methods also to combine paths. So you can find path, combine a path that's a subpart, relative path below another path and combine them together to create a new path. So sort of all of the arithmetic that you might want to do that you might do previously with strings or with files and sort of mixing that together. Now you can take care of it all with paths. And then there are the file operations. So you can actually, trying to think of what falls in this category, sorry. Yeah, if you have something to mention, that's fine.
Well, file operations would be, you had a couple of them back there, which was opening a file to get a channel to a file, moving or copying a file, opening directories. There's a whole series of those.
Okay.
Sorry.
Yep. And the other point here is that all of the methods that access the file system, ones that aren't just syntactical manipulation of the representation, but they really go to the file system, they will all throw an IO exception. So they're not going to just return false if something goes wrong. They'll actually throw a subclass of IO exception that contains much more information about what went wrong. Other files that were involved and details about the error so that your code can actually respond to that and handle or resolve the situation. So opening and creating files. So from paths, you can go to the old IO system. So you can create new input streams to read from a file. You can create output streams. So that way you have complete interoperability with programs that are using the older IO package. So you can have paths, open them, hand the streams to existing code. So it makes it much easier to interoperate with your current applications. You can also work with code that's using NIO so that we can create channels. And we've introduced a new interface called Seekable Byte Channel, which is a byte channel that also has the ability to be positioned. which is nice. That's retrofitted into the existing channels package so that then you can make use of that. It's a little richer interface. It's sort of the NIO equivalent to random access file, which is a very common thing you might want to use. And also the channel has interoperable channel semantics, so you can handle asynchronous closing and interrupting of operations. So we support all the standard read, write, append, truncate, et cetera, of files. And when files are created, also support the ability to set permissions and other attributes at creation time. So you don't have to do a create and then following set, which leaves a window of attack open, where a file might end up momentarily with default attributes or permissions. This way you can get them all configured and set before it's created. So copying and moving files is also supported. The copy to method can copy a file, so the from file that you're calling a method on, to a target file. And there are various options so that you can replace the existing file or not, and you can check that as you pass in. So you can see the flag there, replace existing. And whether or not you want to copy the attributes or not, or have new attributes when you make the copy. So you can effectively use that to do a complete clone of a file and basically get a replica of the original file that way. And the move to operation works in a similar way. In this case, there are slightly different options. Whether you want to replace an existing file when you do the move or not, and whether you require the operation to be atomic. So if the move operation is on the same file system and the platform supports it, the move can be done with a single OS call and it will be atomic. Other cases, it might actually have to be a copy and a delete. And so if your application requires the operation to be atomic, you can pass that flag and it will check that for you and ensure that it does it that way. Symbolic links. So I think this is probably the one biggest thing that was missing, at least from my perspective, because we were using symbolic links a lot in our application. With the old I/O, you could fake a lot of the stuff that we were doing that I mentioned before. You could always write your own copy to methods, move to methods, but really you couldn't do symbolic links without native code. So now we've got this in new I/O. They follow the Unix semantics, so the way they work is modeled after Unix. Most operations will just automatically follow links and do the right thing as if you were using regular I/O on the platform. The links look like they're regular files, except for the delete operation and the move to operation. And those treat links specifically. So by default, if you delete a link, a file that is a link, it will just delete the link. It'll just do an RM of the link. It won't delete the target file. And the move to also doesn't follow unless you specifically ask it to. So those operations have a flag that allow you to specify, but the default is sort of the way you would expect it to be. And each of the different file attribute views, when you retrieve information about a file, about the path, you can tell it whether you want to follow the link or not at that point. Sort of the stat versus lstat. And generally the default would be to follow, but that way you can take a look and decide whether, it depends on what kind of work you're doing there. You can look at the link or the target. So there's also methods then to create the links and read the targets and find out if a particular path is a symbolic link or not. And this all works on Windows Vista, but not quite so well on Windows XP, right? And there's a number of things that you might not think you need, but they're there. They're important when working with symlinks. Is same file to test if two paths are really the same file. They might have different names, but actually represent the same file. So it's nice to have a single API do that for you. I think with current file Java I/O, you have to do some tricks with canonicalization and see if they end up the same, and it doesn't always work. It gives you a rough idea. And copy to operation to copy a link. There's various defaults. To real path is a method that will sort of normalize a path. And there's an option there to tell you whether or not you want it to fully expand. So in one case, it will just do some cleanup and normalize a name. If you pass in the flag to say you want to expand links, it will basically fully canonicalize it. And there's also support, well, there's walk file tree method is a utility method that's provided that takes care of all the details of walking an entire tree of files, which is mostly, there's a lot of details there that you can get wrong. We've written those before, and It's tricky, especially with symbolic links. You have to watch out for loops. And so this takes care of that. There's some options on whether or not you want it to follow and detecting loops and everything for you. And there's also some basic support for hard links. So we can create a hard link and find out link counts on a particular path or node. So here's a quick example of how symbolic links look and are used. So you get a path. In this example, user spool. Maybe it's a symbolic link or maybe not. We don't know. We have a path to it. So we retrieve the attributes. So we're reading the basic file attributes from this file. And false tells it they're not to follow. We just want the attributes of that specific path itself. And then we can ask, is it a symbolic link? And if it is, we can then read the link target and find out. We get the target out of the link, and we have the link. And we can then check to make sure. In this case, we're just asserting that this should always be true, that the file resolved to its target will be the same as the file we started with. So they should both point to the same place. You get that right? So directories, in old file, you basically grabbed a whole blob of directory contents all at one time and walked through that. And that didn't really scale if you had thousands or tens of thousands of files in the directory. Things would just, you fill up memory, things would go very slow. It was not good. So the new I/O, we have a directory stream, which is really like an iterable over the directory contents. So it makes it really easy to just set up a for loop. In this case, we use an external iterator with a new for loop. Pull the directory stream from the directory. In this case, we want to grab all Java files, so we can pass in some filters there. Walk through every entry in the stream. And then the entry is really a combination of, it's a file ref itself and a name relative to the directory. So it's just a little tuple there that you can then grab things from it. You can grab the name. You can actually perform operations on it that are all the basic file operations. So you could walk through and change mod or manipulate the files as you walk through the directory. And at the end, you close the stream when you're done. There's also a shorthand way to do that. We provide an internal iterator approach in a helper method, so you can there pass everything you needed, the directory itself, the wildcards that you wanted to match, and then effectively a callback method or a closure. So this is really designed for use with closures later on if they ever end up in the language. There's a perfect use for them. But that way, all of the iteration and the closing and exception handling is done inside the method. You don't have to worry about it. You just write the code there. So directory stream filters is a class which contains a bunch of factory methods for very convenient for you to create the filter objects that you would use to filter the results of the directory search. Maybe you want to pick up from here. I don't know this class as well.
Okay, sure.
Yeah.
All right, so the directory stream filters is just basically a factory for different useful kind of filters. One of the common ones would be that we've just given an example about there would be something like people want to be able to filter the files in a directory based on their MIME type. So one of the things we're not going to cover today is how MIME type detection works and how it actually plugs into this API. But it's just one demonstration there of how you might actually filter files in a directory. There's also methods in there for combining filters, so things like logical operations and an or complement when you want to actually do filter files. You can actually combine them then together to form little expressions, so it's very, very simple. And the walk file tree method is a utility method on our files class. It's something that Carl talked about in the previous slide, which is basically for walking a file tree, but being able to use it for recursive operations that on all the files that are in your tree. So you basically give it a starting file. Here's what we call my file visitor. That'll get invoked then for each of the files and the directories that are in that tree. It's a very simple to use internal iterator. More advanced applications will actually go and want to develop their own kind of iterators, but this is really for the average developer to be able to develop simple recursive operations. The important thing about it is that it handles things like loop detection. You can set maximum depths and a few other little parameters to configure, so it actually makes it very, very easy to use. Okay, so file attributes. So file file attributes, what we talk about here, we're talking about metadata and other kind of information that's associated with a file and a file system. So things like timestamp, file permissions. There's lots of other very platform-specific metadata that gets associated with files in a file system. The big problem we have in defining an API for this is because it is so file system specific, is how do we fit it into an API that's used by applications that want to be portable. So the approach that we're using is to group related attributes together, and we define what's called a view, or a file attribute view in this case, that provides a view of those attributes. Every implementation supports what we call a basic file attribute view, which is a view of it's kind of a lowest common denominator of basic file attributes that are very common to very file systems. So people know about timestamps like the last modified time, creation time, what the size of a file is, what type of file, very basic information that is very common to many file systems, and that is available through this basic view. We then define all of these other views that are more specific for other kind of common file systems, but they're not required to be there. So we have views that provide a view of POSIX file systems. We provide a view of access control lists based on a model I'll talk about in a few minutes. An implementation then of the platform is required. They support BASIC, and then you may optionally support all of these other views that we define in it, in the API. In addition to that, a platform may support some other very specific file attribute views that would only be interesting for someone that's developing for a particular file system or operating system that we know nothing about. Okay, so yeah, let's move on. So we have a little example here. So this is sort of the Java equivalent of stat in this API. One of the other things that in one of Carl's original slides there, we talked about some of the problems with Java IO file, and one of the big issues that we have to deal with is performance. Many of the methods, in fact, all of the methods in Java IO file today go to the file system. You ask a file, what is your size? What is your directory? What is your last modified time? Every one of those, if you actually profile it, it's doing a stat, or equivalent on the platform. And we end up with performance issues, plus there's potential security issues related to that as well. So what we wanted to do here is provide essentially a bulk read or a stat-like equivalent where you actually read all of the file attributes in one go. So there's a little example here as to how we do that. But in order to explain this example, I just need to explain how the API works. So because we've got all of these file attribute views installed, it's like, how do you actually select one of these? And the way the API works is you select these file attribute views using this type token thing. You basically tell it what you want, and you get back an instance of that. So in this example here, if I had a laser pointer, I'd show it to you here. We call the new file attribute view method. We tell it we're actually asking it for the basic file attribute view. That true or false that at the end there is telling you whether you're actually following links or not. Because sometimes you want to be able to look at the attributes of a link, because by default, if we pick up on Carl's slide earlier on, we follow links by default. Sometimes you want to know, is a file a link? So you can select whether it follows links or not. And then once we've got this view, we invoke, it's got a method here called read attributes. We invoke its method, and it returns you back an instance of this container, which in this case is a basic file attributes. And that has all of the basic things that we would expect. So you can ask it what its size is, what its directory, and there's a few more of the examples there of the methods that are defined by that. Now, when you look at this code here, it's a bit long-winded to do something very, very simple. So we have an attributes utility class, and that defines various static methods for doing most of the basic things that we expect developers to be doing. So Carl has just switched on there, and that code is shrunk down now to a single line. So we invoke this one method called read basic file attributes view on the attributes class. So it makes it a little bit easier. So that is our equivalent of stat in this API. Go on.
Yep.
Okay, so here's another. I thought we'd removed this slide, but okay. So here's another example. This is the POSIX file attribute view. So this is defined in the API as providing access to file attributes that are supported by operating systems that generally implement the POSIX family of standards. A POSIX file attribute view is actually a basic file attribute view, so it extends basic file attribute with some other interesting things. And we have the equivalent of a read method. On the last slide, we had a read basic file attributes that return these basic attributes. Here we've got a read POSIX file attributes. So this is more like a Unix type stat. So a POSIX file attributes, again, is another container. It's actually a basic file attributes plus some additional methods. And in this case, it's returning us back interesting things that we may want to do with POSIX type files. So there's a notion in here of file permissions, file owner, file group, and so on. So we have objects to represent these different things. So in this little example here, we'll just walk through it very, very quickly, is we read the attributes, and we're actually going to print them out. There's a useful static toString method there that actually converts a set of permissions into something that is useful for display purposes. And we do a system.out format. So to print out here, we call the file permissions, the file owner, and the group, and they get printed out in a format that we will recognize. The example goes on there to show the equivalent of changing file permissions. Here we're actually invoking the static method on our attributes class again to set some permissions. We're using the var arg syntax here, so we're giving it a file, and then is basically the array or the list of file permissions. So this is like doing the equivalent of a chmod on Unix. So it's very, very simple to use. We have a number of other file attribute views that we actually define in the API. We've got a DOS file attribute view. This provides access to legacy DOS attributes. So we're always getting requests from developers that want to be able to access things like the read-only, the hidden bit, and all these other bits that you'd actually have. So that's very useful for developers that are working on Windows. One of the interesting things as well is that we actually this file attribute view is designed to be supported as well on non-Windows systems. So for example, if you're using a Samba server or some other kind of CIF server, then on the server side, you can actually change those attributes, and our implementation allows us to do that. We've got an ACL file attribute view, and this provides access to read and write a view of access control lists. The model that we're using here is based on the NFS v4 ACL model. That's the only standardized ACL model that we're aware of. So that's quite interesting. We also support a named file attribute view that's dealing with name value pairs or named attributes that are associated with a file. So when you've got this other typically user-defined or application-defined metadata on file systems that support this, then this is basically providing a kind of a setter-getter type API to that. We've designed this so that it's also mappable to other types of file systems, so it can be emulated by file systems that support what we would call named streams. So there's various file systems out there that support multiple streams, and this is implementable using on those type of file systems. Okay, so we're moving on and just talking about file change notification. So this is something that comes up a lot where you've got applications that want to be able to get events from the file system to tell them when files have changed or be able to monitor files. So this has been popularized in the last few years, typically by things like Linux's IO Notify, and other operating systems have various other kind of notification mechanisms. Typical example you have would be you're in your editor or your IDE. The file gets changed outside of that environment, and the application pops up and tells you, hey, the file has changed. Do you want to load it? So that's a simple example I think a lot of developers would relate to, but hasn't been possible in Java today. A lot of what applications are doing is, and we see this when we're looking at performance of problems, is they're polling at the file system, checking it's last modified, and that can be very expensive. So on operating systems where we can get the notification, then it would be nice to be able to use that mechanism, and that's what we've actually done here. The way it works in this API is that we have a notion of a watch service. A watch service is something that you can register what we call watchable objects with. So you might say, I want to register this file here, give it the name of the path of the directory, and I want you to tell me whenever a file is added to that directory, whenever a file is removed, or if a file is modified in there. And then it provides a notification when there's some event for that object. The way this actually works in terms of the API is it's a relatively low-level API. It works kind of like an event port type of model where you actually get events in a UGQ, or you retrieve keys that represent tells you about the object that has changed. Another interesting thing, I guess, about this API is it's actually designed so that actually you can have multiple threads actually dealing with events. And you've got server applications where you actually have to do some expensive work, where you want to be able to dedicate more than one thread to dealing with events. Then this is actually designed to be able to deal with that. So when you have, let's say, a couple of hundred directories that you're actually watching, it'll actually give you events for this directory, and then some other thread could be processing events for another directory. And by using the API, you can ensure that they actually coordinate and don't interfere with each other. One final point then that we have on this slide is, as I said earlier, that this is quite a low-level API, and it's very much the reason for that is that the actual use cases for this can be actually relatively complex, but what we can do is very, very easily, it's very, very easy to build a listener type of API on top of this, and we have little examples of that. We go on. So here's an example. I'll just run through this very quickly because of time. So we get a watch service here by invoking this static method called file systems get default, gives us a reference to the default file system. We instantiate here a watch service, so you're actually asking the file system for its watch service. I'm building up here a set here of events that I'm interested in. In this case, I'm interested in creation, deletion, and modification events. I register then a directory with this watcher, and I get back this key that represents it. So here we're registering a directory. It may be that you're actually representing other types of, or registering other types of objects as well. And I've got here a little simple loop here that's actually waiting for events to be signals. It actually dequeues or retrieves a key here. And the key has all of the events that are associated with that directory. The way this typically works is that the events come in bulk. For example, someone creates a file, then you're going to get creation events and modification events, and you typically retrieve them in bulk here. And we're actually going to process them. I'm not going to go through, because of time reasons, the details here, but there's basically a loop there that's actually going to process the events and deal with them. So in this case, it's going to tell you when a file is created, it tells you what the name is. If the file is modified, it tells you this file in this directory is modified, and so on. Okay, so quickly moving on, just want to talk briefly about interoperability. So there's Java.io file has been around since JDK 1.0. There's a huge amount of code in there, of code using that. And one of the things we were conscious of is that it will not be possible to migrate existing applications to use a new API overnight. So we want to make it very, very easy to be able to make use of the new features in applications that are currently using the existing Java.io file. So we define this method on Java.io file called a getFileRef, and that returns you back a file reference that accesses the same file as the Java.io file does today. And what that allows us to do is address some of the problems with Java.io file without making extensive changes to existing code. So here's a little example where we're using Java.io file today to rename a file. So this is a bug that people submit almost every month. The rename to method returns a Boolean to say whether it succeeded or not. The rename method returns false if it fails. And you have no idea why it failed. And people get very upset over this because it's very hard to diagnose problems. You guys work on Linux, I guess, but people working on Windows have to deal with a whole bunch of other scenarios and sharing violations that you don't have to worry about. So in this little example here, if the rename to method fails, this little code fragment prints out, your guess is as good as mine, because we don't know. So if we just replace that code, we just change anywhere that's using Java.io file now to source.getFileRef. That returns us our file ref, and then we invoke on the file reference the equivalent method in the new API. So rather than using a rename to with Java.io file, we're using a move to method. So this is just replacing in a very localized way this existing code. So our rename to is now using the move to method. The move to method, as Carl talked about earlier on, is a method that accesses the file system. Therefore, it throws an exception. We've got some information as to why it failed. We're not covering today some of the other details around exceptions, but you can find out there a lot more information about why it failed. So we're just printing out the exception here. So at least we've got, in this particular case, we've got a simple message, or a useful message, we would hope, to explain why why we weren't able to rename the file. Another little point just about interoperability is that we've updated really important classes in the packet in the Java platform. So classes such as Java Util Scanner and Formatter, which are really, really useful for accessing files, so that they work with the new file system API. just briefly talk about the provider interface. So the provider interface is there for more sort of advanced developers that are interested in actually creating a file system for other things. It has a number of usages. The first thing is for the real adventurous, you can actually replace the default file system. So if you don't like the implementation that comes with the JDK, then it's configured so that you can actually replace the implementation completely. Another more interesting thing is that you can interpose on the default provider. So for people that are interested in putting their own caching or their own logging layers in, then you can actually do this. And this is stackable, and it's relatively easy to do. But the other thing then, which is where people want to be able to do their own goofy file systems, is there is a way that they can be plugged into the platform. So you can actually develop your own file system. So I want a file system that accesses files in zip files, or that's completely in memory, or I want to treat this HTTP server as a file system. Then you can go and create your own and deploy your own provider that provides this API to your own file system.
What file system does it ship like?
Okay, so the question is what file systems? By default, it just accesses the platform, and then we have sample code that accesses zip and jar files. Carl, I believe, is actually going to donate another file system provider, and if you do that, we can include it maybe as a sample. We'll see.
So I volunteered to do an in-memory file system. So we have something very similar, parallel in the Blaze VFS that we use for unit testing, which is very handy.
Okay, so just a couple of things just about custom file systems. The way it works is that we have an SPI package, service provider interface package, that defines in there something called a file system provider. You basically create a concrete implementation of this, and you deploy it, and there then is these factory methods on this file systems class that allows you to create them. We identify all file systems by URIs, and so you provide the URI to the file system class, and it'll locate a provider for you that supports that the URI scheme and gives you back that file reference. One thing just to explain is that each of the file systems here are actually distinct file systems. We are not actually supporting federation at the moment. If someone wants to go and develop their own higher-level virtual file system that we're able to mount various different heterogeneous file systems, and they can do that. We're not actually doing that in what we ship with this. So file system providers are currently in our API are deployed as jar files. They're just using the standard service locator facility that's in the platform. If the modules work, ends up in JDK 7, then we'll be able to make use of that. Okay, so just moving topics completely. That's all we're going to talk about for file systems today. I'm just going to talk briefly just about some of the work we've been doing on the channels API. Just explain what we're doing. So, okay, so as part of JSR-51 in JDK 1.4, a new channels API was added, which provides non-blocking and multiplexed I/O. The socket channels, which there's a number of those that are defined in that package, are not a complete abstraction of a networking socket, and so there was carryover work that was not completed in that JSR that we wanted to deal with eventually, so that's what we're working on. So with those channels today, you're actually forced to mix APIs in order to do basic things like binding sockets, binding the channel sockets to ports, setting socket options, and so on. There's some API ugliness in that. We've got some compatibility issues with that. And it's very hard to have these sockets emulate the legacy networking package. So we've attempted to address this problem, and the way we've done this is we define this new interface called a network channel that is a channel to a network socket. Each of the existing channel types have been retrofitted to implement this new interface, and they provide the methods for setting and getting options, binding, getting your local port, and so on. Another point just to make on that is for all the socket options, this has all been made extensible. So we defined a new class that defines the standard socket options that need to be supported by the platform, but it's extensible so that we can make use of platform-specific socket options where required. So instead of having a setter and getter method for every socket option, you can actually implement socket option and just use a set option method or a get option method and just reference your socket option. Okay, another thing that was missing that comes up very regularly is multicasting support. We've had multicasting support in the platform in the legacy networking package since JDK 1.0, but we've never had support in the channels package. So we've added support for this. So we have a new interface here, which you call a multicast channel, that any of the datagram-oriented network channels can implement. And that provides the ability then for these channels to join multicast groups. So Datagram channel is implementing this, and we also have an asynchronous variant of it that will also support this. When you join a multicast group, by invoking this join method, you get back this key. The key then defines, the key is your token that represents your membership of the group, and it defines then methods for dropping your membership or blocking addresses and other queries to ask it information about the group. We've also used the opportunity to try and modernize some of the multicast support because it's actually got quite old in the platform. So there's been new standards dealing with that are defining source-specific multicast. So we've actually used the opportunity to update that. So we have support in there for both inclusive and exclusive mode multicasting. So they're the standards there, IGPv3, and then there's the IPv6 equivalent as well. So here's a little example that just demonstrates this API. There's a bit of code here, but all we're going doing is we're creating a datagram channel. So we're opening the channel, and then we're going setting a couple of socket options on it. We're binding the channel to a local address, setting another socket option, and then the channel is going to join the group. Now, multicasting is a little bit complicated in that you're actually specifying a number of pieces of information. You're selecting what network interface you're going to join the group on, what the group is, and that's the reason for all this code here. But the important points are to look at here are the creation of the datagram channel, and you can see here we're actually using method chaining here. So we're invoking the open method, setting some options, and all of this chains quite nicely. And we skip down then to the membership key equals gc.join, and then you're giving what the group you're joining, what the network interface is. This is the 2-argument join method. We also have a 3-argument one for a source-specific multicasting. And we're receiving a packet, and then later we're actually going to drop our membership. So this has actually turned out reasonably well. Okay, so moving on, I just want to briefly talk about asynchronous I/O, which is something that we also are working on in this JSR. So what asynchronous I/O is about is defining an asynchronous programming model for both files and sockets. One of the motivations really is to be able to make use of asynchronous I/O completion port type facilities that are available on many operating systems. So with our multiplexing and selector support today, we map quite well to operating systems that have a scalable polling facility, but it doesn't work as well when you're actually dealing with operating systems that have event ports that are designed to be able to be used by multiple threads. So instead of one thread doing polling a selector, we can have multiple threads in the kernel actually retrieving events with this kind of API. The API itself defines basically supports two kind of asynchronous programming styles. One is we will be calling future style, where you initiate an I/O operation, you get back a future. This is a Java util concurrent future that represents the result of the I/O operation. The Java util concurrent future has been in the platform since 1.5. It defines methods for getting the result of an I/O getting the result of a computation or I/O operation in this case. Methods for testing whether it's done, polling it, and so on. And the second style then we've been calling a callback style is where you give a little piece of code, which we've been calling a completion handler, that is invoked when the I/O completes. So we start a read on a network socket, and we want this completion handler to be invoked when the I/O completes or fails. So here's a little example. So we have a new set of channels with 4 new channel types that are like the asynchronous equivalent of the existing channel types. So for stream-oriented connections, we have an asynchronous socket channel. We have an OARC open method here that we invoke to create one of these. And in this case, we're going to do a connect method. This is to establish the connection to some remote system. We get back here a future. In this case, we're just going to wait for the result. So get back our future here. That represents our result, and I'm just going to call it get method, which is an existing method on future that just waits for the result to be available. Here, establishing a connection is usually not that interesting. There's no information to provide back. The connection is either established or it fails. We move on then, and we're actually going to do a read on this channel. When you do a read, I'm going to do a read into a buffer. I'm getting back a future, and this, in the case of a read, the result from a read is the number of bytes that have been transferred into the buffer. So, so my future is so if I come down here, I do my get. Again, I'm like the connect. I'm just waiting for the result in this particular case, and I get back here the number of bytes read. In this case, it's actually being unboxed to a primitive integer here, but that's okay. Now the future interface throws when you're waiting for a result, it throws an exception, a checked execution exception, and so we actually have to retrieve the actual exception later on. There's a little bit of ugly sound on that, but for the most part, it fits in quite well with with that API. Moving on, this is the callback style, which is our completion handler. I'm going to do the equivalent read here, except rather than returning a future, I'm going to ignore the result. Instead, I'm going to give it a completion handler. In this example, I'm just using an anonymous inner class. So I do my read on my buffer, ignore the null for now, and I've got here completion handler. The completion handler is a very simple interface that defines a completed method. The completed method is invoked when the I/O operation completes. The parameter to the completed method is something we call an I/O future. That's actually a future, but it's more specialized for I/O operations. It defines this method called getNow, which is a slightly simpler version of the get method for when the result is available, and that returns you back the number of bytes. So this is sort of designed again with the idea of having closures potentially in the future. So this could actually work quite well. So it's relatively simple to use. This is a simple example with the anonymous inner class, but it may be that the completion handler is a much larger piece of code. In which case, passing it as an anonymous inner class wouldn't be the best thing to do. So just quickly, just talk about groups. So one of the big things when you start adding in kind of callbacks or completion handler type of APIs is that one of the first questions you get is well, which threads are going to invoke those the completion handler? And the way we deal with that is that we have this notion of a group, an asynchronous channel group. All of the asynchronous channels that we create here are somehow associated with a group. By default, there is one group, which is the default group. If you don't specify the group, then your channel will be associated with the group. You can, if you want, create your own group. And when you create the channel, then you can put it into the appropriate group. A group encapsulates the various machinery that deals with I/O completion. Retrieving events, doing any I/O completion, retrieving completion events, whatever the platform mechanism might be. And then more interesting for developers is that it also manages the thread pool, which are the threads that execute the completion handler. So when you create a group, you can configure it with the various with various parameters for what threads you would like, maximum number of threads, the thread factory that gets invoked when you create threads, and so on. The group is created with that, and then when I/O is complete, then one of the threads in that group, or the initiating thread, will invoke the completion handler. Now, I said there about the initiating thread invoking the completion handler. That's an optimization in the specification to allow for scenarios where the I/O completes immediately. So for example, I'm writing something to a channel. The chances are that the write will complete immediately because there's space in the socket buffer. You don't want to have a context switch there to some other thread that's going to deal with the completion. You can deal with the completion notification on the initiating thread. So that actually works quite well from a performance point of view. A couple of other things just to say about asynchronous I/O is that we have built timeouts into the API, and this works quite well. Because dealing with timeouts and networking can be complicated. So each of the read and write methods that, in the asynchronous socket channel, we've got variations of the read and write methods that can specify timeouts. If the I/O completion does not, if the I/O operation does not complete within this given time, then it completes with a timeout or interrupted by timeout exception, and that's very useful when you're dealing with servers and you want to time out connections if you don't get a response from some client after 30 seconds or 30 minutes or whatever it might be. Like interruptible channel today, we also support asynchronous close. So at any time, one of these new asynchronous channels can be closed, and any outstanding operations are required then to complete with what we call an asynchronous close exception. One of the things that often people ask about is cancellation. So the future interface, if I've got back this token that represents the result, how do you deal with cancellation? Cancellation typically doesn't make much sense, or it's typically not feasible with I/O operations. So the way we deal with this in the spec is that we allow forceful cancel to be able to close the connection. So a bit like an asynchronous close. So there's a few other little details in that as well. So on platforms where we may have some support for cancellation, then there's a requirement that the underlying connection and the channel is never left in a consistent state. Because otherwise we're into a lot of tricky little problems where you don't know how many bytes have been read or written and so on, and that gets complicated. So the spec has a lot of wording in there in terms of leaving the connection in consistent state if you support cancellation. And finally then, for the adventurous, there is a provider interface, which is in the channel's SPI package, which is if you want to plug in your own asynchronous I/O implementation, then you can. Okay, so we just do this one slide. There's a couple of other little things that we have in this JSR as well. We have defined a new set of buffer classes, which we call big buffers. This is kind of a little bit niche in that it's really designed for cases where you want to have multi-gigabyte containers in native memory. It's very much designed for the sort of the 64-bit type application where you have loads and loads of memory available, and you want to be able to map very large files into memory, or you want to have other big, large native databases in memory. So this is a parallel set of buffer classes. Everything is indexed here by a long rather than an int. So we have then a way that you can actually create views, 32-bit views into these larger buffers for interoperability with existing applications. One final little thing, which is a small thing that we included in there, was we've also included a management interface for buffers. The motive for that is to be able to for JMX and other type monitoring applications, to be able to monitor the resources that are associated with direct buffers and memory mapped files. We'll skip the next one. Yep. Okay, so just to conclude, so we've just provided an overview there, a quick overview of what we have in this API. This is still ongoing, this API. We hope to get into JDK 7, and we've hoped by going through these slides that we've given you an overview of the type of problems that we're actually trying to address, what the APIs might actually look like, and hopefully you'll find it useful. So we have a couple of links there. There's the links to the JSR page. So we just recently got set up as a project just in the last week on OpenJDK. So that at the moment it's because it's only just set up. It's only just got the current snapshot of the code. So you can actually download that, apply the patch to your OpenJDK, and it'll work. In a few weeks' time, we'll actually improve on this so that there'll be a proper repository there. We'll have binaries, JavaDoc, and everything else, so that because we've basically got two audiences for this: people that want to play with the code and people that don't care about the code. They just want to try out the API. So we'll have all of that set up soon. We have 2 mailing lists then. So we've got a development mailing list that we're going to be using, and then we also have a general questions and discussion alias. Okay, I guess that's it.
You want to take questions now? We have a mic. I think that's set up. We could do that, or I'll pass it around.
We can repeat the questions. There is one. Okay.
Let's try that.
Sure.
I have two questions, the first of which I hope is quick. I noticed that when you retrieve an attribute view, you seem to be passing in a Boolean, whereas in other cases you have this nice follow link, no follow link attribute. Is there a reason behind that?
Okay, so the question, well, okay, I guess you have the mic, so. So anywhere where you, where there's a choice as to whether you follow it or not, there's a Boolean argument there.
Okay.
Now, I think what you might have noticed is a no follow link, which is
right.
like copy options, and the reason for that is that something like a copy to method, you're actually giving it we're using the var syntax where you're giving it a list of options, and we can't just put a Boolean in there. One of the options is no follow links for the rare cases where it's more interesting to copy the link rather than the final target of the link. I think there's only two places where we actually do that.
I think maybe he's arguing for having the enum being used instead of the Boolean.
Yeah, I'm wondering why you ever use a Boolean.
Hey, we could do that.
We could have a static final Boolean.
We could do.
No follow links, right?
Yeah, we could actually do that. I think one of the other things we want to do with those as well is for most of the time you're only interested in following links, so we can actually just eliminate that argument completely. So yeah, okay, so you're right. There's a little bit of inconsistency there.
Okay. And for people like me who are interested in implementing their own file systems, your source code showed path.new or get with a string, and then operations on the path to obtain a channel. How does it tell which file system to use to get a channel?
Okay, so that path get method, which is specified to make it very simple for developers to be able to actually just reference a default file system. That actually invokes a get path method on the file system.
So the code that I'm using has to know that it's being written for custom file systems.
Correct. Yes. The other.
Well, it's not so much that a custom file system. It just has to be able to take a file system instance as an object to work with. And from a given instance of a file system, you can then...
Right, so if we eliminated those get methods, which is what we could do, that means that everyone then, in order to access a file, they've got to call file systems.getDefault and then call its get file. So it's a little bit harder for the average developers.
Now you can also get a path from a URI.
Yes,
and the URI can have the encoding of the URI, that the type can indicate which file system to go retrieve it from.
Yeah.
So the file systems manager will look up the right file system. So you can have like jar : foo will know to go get the jar file system, or mem : or anything you want.
So there is only one method. There is only one method that always goes to the default file system, and that's that. That's the get method that takes a string. Yes, and it's because it's to make it simple for the common case.
But you can change the default file system.
Yes, you can.
Which will break all sorts of things. Depending on where your connect files go. Right, depending on what implementation.
Okay.
Martin has a question.
So, Alan, as you know, I have a one-track mind. The only application I really care about is RM-RF, and which is surprisingly difficult to get right.
That is a really hard problem. Okay, so one of the things that we did not cover today is something which we call the secure directory stream. The secure directory stream is a specialized type of directory stream that allows you to deal with race-free operations in the file system. So you can actually cast your directory stream when you open the directory to a secure directory stream. And the secure directory stream provides then operations that work relative to the open directory. So your attacker, which I think is what you're thinking about, is moving or swapping the directory.
Right. So someone leaves the company and they leave a program running that makes symlinks to / and then removes them in an infinite loop. And meanwhile, the system administrator does RM-RF, except it's written in Java, and you want to not remove all the files in the company.
Right. And the only thing I can give you is the secure directory stream for that, because it's a really, really hard problem.
Now, you could actually provide something like a higher level thing to say, remove this directory recursively, which you could provide the higher level thing, but it would be nice if if there was enough infrastructure to be able to provide the lower level as well.
Yeah, so the infrastructure we have for that really is the secure directory stream. So we're not providing the equivalent of a chadr, which is the way a lot of these Unix utilities actually work. Is the best we can actually do is the star-at type of API, which is what the secure directory stream gives you.
Speaking about recursion, you mentioned logs. Is that full logging with star as well, or is that just logging within the directory?
It's just within a directory. You can. There's actually a name matcher there, so if you want to do something a bit more complicated with star, then you could do that.
Okay. Yeah, let me give you the mic. Okay. There you go, Kevin.
Those static methods that you have, which actually go out and access the file system, do they all have alternatives that would just be instance methods on the file system instance or via the file system instance?
Yep.
So if I wanted to make sure that all of my accesses outside, all of my I/O was happening not through static methods, but through a chain of instances, I could just do that. I wouldn't have to use any static methods.
Yep.
Yes.
That's what I wanted to hear. Okay.
Yeah, the static methods are generally just convenience methods that wrap some existing instance methods. Oop, mic to the back. I'll just be the mic guy, I guess.
I'm just curious, for using the file system for multimedia applications, do you guys have any way of reserving performance or promising performance, or are there any calls to tell you how well that system performs, so you know that you can stream things out of it? Or
We haven't covered that topic.
Haven't thought about that. Okay.
That would maybe be something on file store, but kind of an extended attribute on file store. Yeah, don't know.
Yeah, potentially. Oh yes, okay. Yeah, so today we just talked a bit about file systems file attributes, but we also support access to file store attributes. I don't know whether whether the information about performance is something that's available for a particular file system or a particular volume or whatever. If it is, then this is potentially you could actually get to that information. So the only file store attribute view that we require in the platform, in the current version of the API, just provides information about space information. So how much space is used, how much is free, that kind of stuff. But as per the file attribute views, this is extensible. So if someone wanted to actually develop their own view of some other more interesting file store or volume attributes, then they can actually plug this in.
Yeah, I guess my concern would be that if you want to guarantee a certain performance while you're streaming something, whether there's
no, there isn't.
That reservation would happen on the store.
Yeah, there isn't a reservation API in there. Yeah.
No more questions? Well, thank you all for coming to our talk. Thank you.